Okay, we're back. All right, we have the most intense parallelogram problem you're going to see in quite some time. So this is a parallelogram, and we drew in some diagonals. And when we draw in diagonals like this, if you try counting the number of triangles that we just created by drawing in the two diagonals, it looks like there's four, but if you really look carefully, there's eight altogether. Look at all the overlapping triangles. And so this is an intense problem for a few reasons. Is because very soon we're going to be connecting a lot of geometry that we've talked about in previous chapters. Well, the angle sum theorem is going to come to life. And what else? You got to look for linear pairs. And what else? You're going to see lots and lots of alternating interior angles because we have parallel lines. And then we're going to have lots of straight angles. They always equal 180 as well. And then we have same side interior angles. They're always supplementary as well. And then we have the tricky and very sneaky exterior angle theorem that we're going to be able to showcase as well. And then we're going to have the standard, very common vertical angles as well. So it's all connected in this picture to find all the angles. And so the reason why this picture becomes intense is because we draw in two additional lines in here, and these two additional lines are going to create many more triangles. And not only do they create more triangles, these two additional lines that I just drew in, they are also parallel as well. And I'm not even going to bother counting, but all of a sudden we have a lot of parallelograms. Just to showcase, most people see what we started with, the largest parallelogram in here, but if you take notice, there's parallelograms here, there's parallelograms here, and there's some here, and there's some here, and then there's several more. Where are the other ones? Well, there's some over here, and there's some over here. So every property, and we also have some other ones. We have this one here and that one here. Oh my God, this is like super intense. Every property that we talked about and learned so far about parallelograms, they always come to life in this type of picture. So where are we going to start? Well, the only given information we have are these three angles in here. And so I'm going to randomly start with one of them. I'm going to start with 20, and then I'm going to continue to show you what I see. Well, right away I see that 20 is alternating interior angles to this angle up here. That's nice. But if you look carefully, not only is it alternating interior angles to that angle, it's alternating interior angles to that angle as well, making that angle 20 as well. And so if you notice, this angle is 20, and then I also see vertical angles, that's 20, and that makes total sense because if this one is 20 up here, this is going to be 20 there because they're alternating interior angles as well. So that's 20 degrees right there, and look how it shows up. It shows up as alternating interior angles in a few different contexts with different parallel lines, and it's also there's a set of vertical angles. Let's do the same thing with the 50-degree angle. The 50-degree angle is alternating interior angles to this one here, and then I see vertical angles to that one in here, and then I see another set of alternating interior angles with that angle right there. And so we could do the same trick with the 70. So if that one's 70, I can use this one as alternating interior, or I can just jump to the other side and say that one is alternating interior. And I can also see the vertical angles as well. That one's 70 degrees as well. So where do we start? Oh, there's so much geometry just flying at us right now. There's the angle sum theorem. We can look at any triangle and see if there's any two angles we already know, and then we can find the third one because the third angle will add up, make the sum total to be 180 degrees. We can look for consecutive interior angles. We can look for linear pairs. We can look for straight angles. There's no right or wrong where to start here. There's just so much we can explore. I'm going to focus on this triangle over here. Well, that triangle has to add up to be 180 degrees, and so far we have 50 and 20, that's 70. So that's a guarantee that this angle has to be 110. If that's 110, I can immediately see that that is a linear pair, so that has to be supplementary. Well, I'm going to take those two angles and I'll jump to the other side of the triangle. Well, why would this one be 110? If you notice, that's alternating interior angles as well. If you just kind of turn your head sideways, most people can see that the 110 and 110, they're alternating interior angles as well. And then if that's alternating interior, well, this is 70 for a few reasons. One, that's a linear pair, and also the 70 degrees, they're alternating interior angles as well. Let's keep on going. I have another triangle I can focus on. I'm going to call this one my little green triangle in here. Well, ooh, that's interesting. I've noticed I got two angles that are both 70. That can kind of imply something about their sides as well, but that's a different connection. So we're just going to focus on the angles. Well, if I have 70 and 70, that's 140. So this angle has to be 40 for a couple of reasons. One, it's the angle sum theorem, and also all of these angles in here along this straight line, they have to add up to be 180 as well. So if you noticed, 40, 70, 50, and 20, that adds up to be 180. That checks out. Well, all of a sudden, if that's 40, ask yourself, why is that one 40? Well, that's alternating interior angles as well. Ask yourself, look, if that's 40, why is that one 40? That's right, that's a vertical angles. And if this one's 40 right here, why is that one 40? Well, we got alternating interior angles as well with 40. So we know a lot of information. There's just a few more angles left to find. Let me focus on a different triangle in here. I'm going to focus on, which one? I'm going to focus on this yellow triangle right here. Well, that yellow triangle, I know two angles. I can find the third one. 70 and 40 is 110. That's 110. This angle has to be 70. And if that's 70, this has to be 110. That's a linear pair. And if that's 110 and 170, this has to be 70, and this has to be 110 for so many reasons. The angle sum theorem, alternating interior angles, and also consecutive interior angles as well, otherwise known as same side interior. So I think we got it. Look how intense I was. We have so many different concepts in geometry all rolled in together. Maybe you can see them now, this list of concepts in relationship to the picture. We have the angle sum theorem everywhere. We've seen linear pairs. We have seen, what else? We've seen tons of alternating interior angles. We see several straight angles here. Same side interior. I'm just going to showcase one same side interior here. If you notice, that's 70 degrees, and this is 110 degrees, and 70 and 110, that's 180 as well. And what else? Well, I didn't talk much about the tricky exterior angle theorem, but if you take the yellow triangle, for example, notice 110 is the exterior angle to that triangle, that yellow triangle. And 110, the exterior angle theorem says, the sum of the two remote interior angles is going to be equal to the exterior angle. And so it takes a little bit more study, but there's tons of exterior angles in this complex picture here with assorted parallelograms. And then the last concept we touched on is vertical angles. So I hope you enjoyed that intensity of that problem with multiple parallelograms and all these concepts rolled together. And check out the next video.